Hi everyone. I hope each one of you doing fine and staying safe. Welcome TGIF, a topic which we have been wanting to talk about for some time now. And as a team, we've been researching a lot in this area, which is autonomous systems. Yes, automation to autonomy. This is a topic we're going to talk about. And as Microsoft, we have a platform offering called Project Bonsai. And we'll discuss more about this in today's episode. So with that, let me welcome Shika Agarwal, who is data scientist at MTC Bangalore, who is an SME on the topic. So welcome TGIF, Shika.
Thank you, Sandeep.
Perfect. So Shika, if you look at it, machine teaching as a philosophy has emerged, right? And as Microsoft, we're leading that trail of innovation. So help us understand in simple terms, what is machine teaching?
Sure, Sandeep. So machine teaching is, a very revolutionary concept by Microsoft. Now, traditionally, when we talk about machine learning, we talk about data, right? So an algorithm essentially observes the data, discovers patterns from it, and trains itself via self-learning. Now, while machines do a super job of unlocking insights when we have millions of data points, now the outcomes are quite inferior when data is limited. And so, to tackle this problem, Microsoft has pioneered this revolutionary approach called machine teaching, wherein machine learns not just from data, but actually by teaching. So this is really all about expressivity. I mean, being able to understand what a human is trying to teach, and HCI or human computer interface becomes super important. So let me explain all this with the help of an example. So let us say I wanted to train a machine to learn how to buy a good car. And what I would do is point to the features like what's the mileage, whether it's electric, what are the safety features, and so on and so forth. And that is exactly what we do in machine teaching. So now, ironically, in traditional machine learning, we feed to an algorithm label data. And how we label data is by looking at the features. Algorithm, on the contrary, looks at these labels and tries to learn those features. So, I mean, it makes complete sense to then impute these labels all together and make the model learn right from the characteristics. And that's what we do in machine teaching. And to support all this and take out all the complexities, Microsoft has unraveled this platform called Bonsai, which makes it super simple to build autonomous systems.
Again, we call it a low-code industrial AI platform, which you mentioned, which is Bonsai, right? Why don't you give us a glimpse of Bonsai as a starter?
Sure. So as you mentioned, Bonsai is truly a low-code AI platform that simplifies machine teaching, what we just discussed, with deep reinforcement learning so you can train and deploy smarter autonomous systems. So Microsoft Bonsai comes equipped with multiple simulation environments. So things like AnyLogic or MATLAB Simulink, all these are well supported. And of course, you can have your own containerized Python environments as well. So for example, if I wanted to train my model to trade autonomously, I would set for it an objective of maximizing the profit and avoiding the risk. And once the model is trained, the trained brain can be deployed for it to be consumed as an autonomous system.
So it will be great if you can showcase one use case and we can take it there.
Sure. So what you see here is the Bonsai platform, right? And here we are training, a Moab to train this ball to stay at the center and not fall off. And you can see what you see here, is a model that has been trained already. And so you see, just as the ball tries to fall off, the algorithm kind of tilts the lever so that the ball comes back to the center. And let me show you how simple it is to actually kind of specify the objectives here. So, all you say as your goal is to avoid falling off the plate and drive to the center center of the plate. Using this, we can create multiple applications. So let me show you an example of that. So here what I have is like a factory environment wherein I am actually recycling plastic bottles to create ping pong balls. And so there are multiple processes happening here. So I'm recycling the plastic, I'm forming the plastic, and here I'm trying to do precision joining. And so let me show you how using autonomous system, I could actually, fine tune this process and achieve better quality and better efficiency, right? So let me start the scenario here. Now, as you can see, like any other process, there are multiple parameters that I need to take into account, and using those parameters, looking at those parameters, adjust various machines to get the calibration right. So a human would typically do something like this. As you can see, this is going to be fairly time consuming and error prone. And if I were to do that using AI, it is automatically figuring out the right calibration. And you can see in very small span of time, very short span of time, it is calibrating the machines repeatedly as the environment changes, guaranteeing us the quality and increasing the efficiency many folds. So this is just one small example of what autonomous systems can do for you. It is really up to us to use this to create systems we want.
Shikhar, thank you so much. That was impressive. That's the world we all want to move into. And, we've definitely gone beyond 5 minutes, but I'm happy we spoke about the topic. And for all listeners, we're going to make it a series very soon because this topic needs a lot more episodes for us to do justice. So look forward for that. And for listeners, thanks for joining in. Happy Friday and have a wonderful weekend ahead. Bye-bye.
Thank you, Sandeep. Bye-bye. Have a great day.